Hello, I'm Dan DeBacker. I lead the service provider product management and engineering team here at Extreme. And in today's session, we'll talk about building the carrier grade data center. So let's get started. There are three different design tenets that we look at when building the data center. First, it's scalability. Now, this may not be exactly how you would define scalability. A lot of times we talk about scalability in terms of the amount of bandwidth or the number of ports. And in this case, I want to talk about the circumference of the data center. We're expanding well beyond the traditional walls of the data center. And we'll talk about this more in the rest of the presentation. Secondly, composability. Creating an extensible infrastructure, a singular infrastructure that is composed to fit your business needs. It's not a one size fits all. We want to make sure that we can create an infrastructure that is very flexible and adaptable to exactly what you require. And lastly, visibility. How do we turn data into actionable information that can be used? So how are we going to do all of this? Well, we think it's all around hyperautomation. So what does that really mean? Hyperautomation is the concept of our ability to design, discover, and provision a network, in this case, an IP fabric. We then continually monitor and validate the fabric and also provide the capability to remediate any issues that may be encountered. This really becomes critical as we build the next generation data center and that carrier grade data center. Hyperautomation provides us the capability to manage a very scaled environment. So now we're not only managing one large data center, but we're managing multiple data centers across wide geographic regions. Hyperautomation is really the tool, the engine that allows us to create this composability. Our ability to create that fabric exactly how we need it, exactly how we want it. Expand it, reduce it, grow it. All of these things can happen through hyperautomation. And lastly, hyperautomation also provides us the ability to get that visibility, the visualization of what's happening across our entire network from one singular position. So this is a very key point that hyperautomation really enables these three tenets of the data center. Now let's break down the various components inside that data center. It's really very simple. Three areas. We start with the platform, the Extreme 8000 series and SLX series. We move up to the operating system. SLX OS is the engine. And then lastly, the application. Here, Extreme Fabric Automation, the ability for us to start that journey into hyperautomation. But now let's look at each of these in terms of different areas. First, let's talk about security. So with Extreme Fabric Automation, I want to make sure that we have authenticated management across all fabrics. So authentication, authorization, encryption, all of these things are very important to make sure that we can manage this environment securely. From SLX OS perspective, we have security in the control plane, the data plane, and the guest VM. And from the platform perspective, something you may not even be thinking about, but a concept that we call trusted delivery. So we want to ensure the integrity of that platform. And we'll talk more about exactly what that means in the coming slides. Next is robustness. So what does that mean, robustness? Robustness is really how resilient is this infrastructure? So as you can see in all these different areas with Extreme Fabric Automation, it's all about stateful high availability. We have a concept of drift and reconciliation so that if anything happens within the fabric, any kind of parameter changes, we continuously monitor and validate those configurations and we reconcile them. From an operating system perspective, robustness is pretty simple to define. Sub-second failover and recovery for all single and double faults. Yes, double faults. So when we look at something that needs to be carrier grade, it's not just being able to adjust for a single point of failure, but for multiple simultaneous failures. And then when we get down to the platform level, robustness is really about the resiliency of that platform. And in the case of a carrier grade infrastructure, our ability to actually have redundant management access, always having the ability to get to the platforms and provision the fabric. And lastly, dimension. Dimension is really about scale and performance. So with Extreme Fabric Automation, we have the ability to deploy it on box versus off box. We talk about different scale and performance parameters there. From an operating system perspective, it's an IP BGP fabric. So this needs to be highly scalable, all the features and functions across the entire fabric. And then from a platform perspective, really the dimension talks about the topology. How big do we need to make this topology? Is it very small? Is it a medium size? Is it very large? How do we expand or contract that topology? So the dimension becomes very, very important. And again, not a one size fits all. So if we look at the platforms and the topologies, we can see here that there's 3 different topologies shown. The small data center fabric, which can start off as just a simple 2-switch pair, move up into 4 of those pairs. Then we go into more of the traditional 3-stage CLO and 5-stage CLO. Now, in all cases, you can see we have different platforms that are available to fit different places in the network. And some of these can be multifunctional. The SLX 9250, 32 by 100 gig. That switch can sit either as a leaf or a spine. So we have a lot of flexibility in the platforms and where they can live. Again, really talking about how do we create that topology that best fits the use case you're looking for. So now let's dig into platform security. This is an area of great interest across the industry. A lot of issues have been happening lately within the world from a security perspective, which really shines a light on a lot of different areas that we may not have taken into account in the past. So today we have the SLX 9250 and 9150. You can see the port combinations. Later in 2021, we will be announcing and releasing the 8720 and the 8520. So what are the differences here? They're actually really based on the ability to provide more secure capabilities within the platforms themselves. So the first concept that we'll talk about is actually kind of in the middle of that slide toward the bottom there is measured boot. We have added hardware inside of these 8000 series platforms that allows us to have a hardware root of trust and the ability to support measured boot. Now, that's only really one piece of this entire security puzzle. When we talk about trusted delivery, it's really the assurance that when a switch leaves manufacturing, goes through distribution, arrives at your site, we know that it is fully integrity capable. We don't have to worry about the fact that it's been tampered with, that anything has been added to it, anything of that nature. Now, the next step is that we go through a measured boot process. So we validate everything is what it should be from a security perspective. Everything looks good, and then we actually boot the OS. So there's a lot of different areas that we're adding into this entire process to really ensure that when you have a switch and it boots up and it's part of your network, you can absolutely be assured that there's nothing has been tampered with that from the point of manufacture to the point of installation within your network. So these are some areas where we'll continue to enhance security. And again, a lot of times when we talk about security, we think about network access control and ACLs and things of that nature. I mean, this is really security at a much lower level before any of those things ever take place. But again, with a lot of things happening in the industry across the world, these are the types of things where we need to make sure that we protect our customers against and provide the most secure infrastructure possible. So well before this box even boots up, we want to make sure that it's trusted all the way through this process. All right, let's get into the IP fabric. So very standard IP fabric, a leaf, border leaf, spine. This in this case is a 3-stage CLO topology. So what are the things that we think about when we talk about carrier grade data infrastructure? Because this looks pretty common. This looks like pretty much what everyone else in the world is doing. And that's actually a good thing. We want to make sure that we are fully interoperable, standards-based. But there's a lot of things that have to happen on top of that for us to declare this as a carrier grade data infrastructure. So let's start with redundancy. Redundancy is pretty simple. It's multiple physical components, eliminating any of these single points of failures. So I threw one example down there as a dual top of rack switch with dual homed endpoints. So I have my compute devices here shown, all of them dual homed into dual switches. So everything redundantly connected. Then we move into resiliency. So resiliency is really the ability to have multiple logical paths throughout the entire infrastructure. So I want to have redundant links, but I also want to make sure that I'm taking advantage of those redundant links with multiple paths through the infrastructure. And again, here, a very simple example, equal cost multipath and resilient hashing for really the ability to make sure that I'm utilizing these links, ECMP, and then resilient hashing saying that if there is a failure, I have consistency in my data flows. Then we go to the third R, reliability. Reliability is, in this case, sub-second failover and recovery for all planned and unplanned events. So there's a lot of different ways that we can achieve reliability. In this case, I'm talking here about BFD, bidirectional forwarding detection, and LACP short timers. So we want to make sure that we can maintain that integrity of the fabric itself and that the fabric is very reliable. So failures are going to happen. We want to make sure that we have fast failover, fast recovery. And in planned events, when we want to do fabric-wide upgrades, we want to do those upgrades in such a manner that the resiliency is to a level where it's nearly hitless. We don't really interrupt any services as we do those planned upgrades across the fabric. So resiliency and reliability and redundancy, all three of these really come together, building upon each other to create that carrier grade infrastructure. Then we get into scale. So we talked about dimension. Dimension and scale really mean the same thing. So I want to make sure that I can physically scale my environment, that I have the right amount of bandwidth, that I can add bandwidth. So I can scale up, scale down, scale out, scale in. All of these parts and pieces come into play. So there's the physical connections. There's scale within the control plane, the data plane. So a lot of different components come into play, and all of them need to work together to create this truly scaled environment where I can continue to add compute. I can add bandwidth. I can add leaf switches. I can add spine switches. I can increase my bandwidth to reduce my oversubscription. So all of these parts and pieces come into scale. So now we have all of this. And we obviously do a lot of different types of testing to make sure that all of these things work in all different scenarios. But the thing that we've really added to really take this to the next level is chaos monkey testing. So what are all of the different crazy scenarios that we could probably come across and test against? This is really one of the things that takes it to a level that we feel makes it carrier grade. So simple testing that everyone else in the world does, basic testing. If I pull a link, I put a link back, I power off a switch, I power on a switch. All of those things are normally tested. But on top of that, we add a much more layered approach from a testing perspective, doing things much more, it may seem crazy, the different types of tests we run, but it really puts us into the position where, again, we can talk about single faults and double faults and make sure that the fabric is still very resilient, reliable, has the redundancy built into it. So this level of testing is really something that makes this a truly robust infrastructure. So that's really how we get to that point around carrier grade. There's a lot of parts and pieces that come into play for this. So it's not just one piece. It's not just having a switch with redundant power supplies or having multiple links. It's not having just a scaled infrastructure. It's not just doing testing. It's all of these things that come together that really form this entire infrastructure that becomes carrier grade. Now let's talk about hyperautomation. In this case, hyperautomation, we're achieving this through extreme fabric automation. Extreme fabric automation is an application, but it's an application that we provide at no additional cost. There's no additional license for Extreme Fabric automation. The cool thing here is that it can be deployed in two different ways. It can be deployed on box. On box means that it runs inside of a VM inside the switch itself. As you can see at the very top there, the picture on the right-hand side shows my two spine switches with VMs running on those spine switches, Extreme Fabric automation installed on both of those, running in a full stateful high availability mode. On the bottom right-hand corner, the picture shows the same exact scenario, but we run those, the Extreme Fabric automation off box, just on generic servers. So the nice thing here, you have a lot of flexibility in how you want to deploy the application. But in both cases, this is an application that runs full high availability mode and is really that catalyst engine for hyper automation. So let's dive a little deeper into what that really looks like. Extreme Fabric automation is a microservices-based architecture. So as you can see across the middle there, we have foundational microservices, and on the right-hand side, ecosystem microservices. So this is how we can integrate OpenStack, VMware, Microsoft into this fabric without having to do anything specific inside the fabric or the OS. We've created this abstraction layer where now we can really create the capability to use OpenStack to provision the fabric, and the fabric has no idea that OpenStack is what's provisioning it. So the beauty of Extreme Fabric automation is that it can act as that middleware. So we have a lot of different access options. There is the CLI. There is an API gateway that sits inside of Extreme Fabric automation. So any orchestration tool can use APIs to provision. And then as mentioned, we have the ecosystem parts and pieces there that integrate directly in. So you can see the foundational microservices. This is much more than just an automation tool. And so we will continue to advance the capabilities of this. And hence why we're moving from just simple automation, which really is just the provisioning of the infrastructure or the provisioning of the tenants, into that concept of hyper automation. So really taking it much, much more deeply into monitoring, validation, and those types of things. So as you can see here, I won't read across all of these, but we've got a lot of different services that take care of specific functions. So fabric provisioning, tenant provisioning, authorization and authentication, inventory. So the beauty here is that we have this application that sits in the middle between the user and the fabric itself. So this becomes my single point of truth. I literally do not have to log into any switch or router to do any kind of configuration. All of that is done through Extreme Fabric automation. It becomes a single point of truth for the configuration of the fabric. It does the continuous monitoring and validation so that if something does happen inside the fabric, I can reconcile that with what the intended configuration is supposed to be. We've added a lot of other capabilities and features within EFA and the fabric itself to really ensure, again, that go back to that same word, integrity. So a quick example, if we have two switches that are a pair inside the fabric, one switch is down, the other switch continues to be provisioned. When we bring up the switch that was down, we bring it up into something called maintenance mode. So it's available from a management perspective, but it's not forwarding traffic. EFA will then interrogate the configuration and make sure that the configuration is exactly what it should be. It should match exactly its pair. Once that happens, we take that switch out of maintenance mode. EFA does this automatically, and it begins to forward traffic. So we are in a position now where a switch inside the network will never be online and forwarding traffic if it is not provisioned as it was originally intended. So again, gives you that rest, the assurance that this fabric is running and it's configured exactly as I expect it to be configured. So if we look at some of the values here around hyperautomation, we talked about this validation. So the other piece of this that I didn't mention yet is the pre-provisioning. So before we ever provision the fabric, we will go out and interrogate the physical connectivity of the fabric to make sure that everything is cabled up correctly. So if I'm expecting it to be cabled as a 3-stage flow and something is cabled incorrectly, we will flag an error and we won't provision it. We talked a little bit about the continuous monitoring, that drift and reconciliation to make sure that things are configured as expected. Some of the other cool things, fabric-wide firmware upgrades, fabric backup and restore. So we want to create an environment that is much easier for our customers when we look at how do we do upgrades? How do I ensure that I'm continuously backing up the configurations, that I can do an RMA, I can return a switch, put a brand new switch in, it automatically gets the configuration that it should. All of these things are now taken care of through this hyper automation platform with Extreme Fabric Automation. So we continue to enhance the capabilities of what are the things that I have to think about from an operations perspective. How can I simplify that? How can I remove the human error factor? How can I have an application really just take care of my fabric for me? The other key piece around this is that this is not just for the physical fabric infrastructure. This is also for all of the tenants. So I need to provision VRFs and VLANs. I need to provision port channels and things of that nature. All of my tenants, all my connections into the fabric. So Fabric Automation maintains all of that information too. So the drift and reconcile is not just for my BGP connections, but it's for all of my tenant configurations also. So really, when we look at this, it's a full encompassing solution to really maintain that entire configuration across all aspects of the fabric. So what's happening? Where are we going? What does the future hold for us? We know that, first of all, 5G is going to unleash a tremendous amount of data. And so it's really not necessarily about the 5G technology in this picture, but it's really about what 5G is going to help enable for us in the future. So more bandwidth, farther out, more applications. So the concepts, like I said, that the circumference of the data center is going to get much bigger. So today we really have centralized data centers. But what we can see here is that the data center concepts will really get into more of a tiered structure where we have centralized data centers, access data centers, and then we have the edge. So MEC, the multi-access edge compute solutions. So now my data, which in the past was all funneled back directly into the centralized data centers where all of my applications lived, will continually merge its way out further and further. So what are the applications that are going to drive this? Some we know, some we don't know yet. We look at the amount of data that's going to be there from autonomous vehicles, from different IoT applications. So more and more of this information is being proliferated further and further out. So now when we look at how do we create this carrier grade data center, the carrier grade data center is no longer just this big central office, but now it becomes more of access and edge. And as we spread things further and further out, we need to have much better visibility. We got to have scalability. We want to have composability. So it all goes back to those basic 3 tenets that we talked about earlier. It becomes really, really important as these things start to grow, because now I need to have a much larger span of control. So you can see there at the top, visualization, telemetry, analytics, monitoring, validation, AI, ML, remediation. All of these things become more and more critical the further and further that we stretch this out. How am I going to as a human, how am I going to be able to know all and have visibility into everything that's going on? We have applications now that sit out at the edge where traffic just comes in and goes right out, never comes back into a centralized data center. Yet I need to have visibility to know what's going on. I don't have the ability to really consume all of this. So the analytics and telemetry data needs to be converted into that usable and actionable information. I can't just look at a bunch of data and try to interpret it anymore. The amount is just way, way too big. So I need the ability to take that, convert it into something that I can look at, make sense of, and take action on. And better yet, do all of that, but have the automation, the hyper automation piece, take action on it for me. So the remediation pieces become even more critical. So bigger, faster, stronger. And I need the tools, I need the infrastructure and the tools that allow me to really make this work for me. So we're in exciting times. I think you will see this evolution happening. It's really not if, it's when, and it's really how big and how fast. So these are the things that we want to make sure we have an infrastructure that is ready to support. So in summary, we need to prepare for a different type of scale. We still have the scalability within the data center, still very important. We're moving from 10 to 25 to 100 to 400 to 800 and beyond. So within the data center, very important, but now it's also across. We need the ability to tailor solutions to the need. So it can still be standards based, but it has to be flexible. It can't be a one size fits all. It needs to be tailored to fit the needs of the use case. We can no longer afford to just build all these very rigid silos. It needs to be adaptable and flexible. And lastly, as I said, visibility, visibility, visibility. I mean, ML and AI will become your eyes and ears across that entire infrastructure. You're really not going to have a choice because there's just going to be an insurmountable amount of data and information that you just won't have time to look at and to process. So I go back to hyper automation. Hyper automation is really the key around all of this. It's how we bring all of these things together. So I really want us to get away from the fact that we have a provisioning tool. We have a monitoring tool. We have a visibility tool. We have different analytics things. All of these things now need to come together into this platform of hyper automation because they all need to interact together. So we're very excited about what the future holds. We're building solutions today that are carrier grade. We'll continue to enhance them, build them, make them bigger. And so we're very excited about today and moving forward. So with that, thank you. I hope this session was useful, provided you some good information. Thank you very much and have a good day.